Today, we want to talk about Excel functions and formulas I believe every data analyst must know. During our data analysis tasks, we will always come across different instances whereby we need to carry out some computations. It could be small or complex calculations that involves the use of formulas and functions. Now, Excel has very rich functions and formulas we can use for almost any kind of calculations, be it scientific calculations, be it mathematical calculations, be it statistical calculations, be it financial calculations. So Excel has very rich functions and formulas we can use for our computations. Now, let's explore the difference between functions and formulas. Now, functions are inbuilt programs that have been written so that we can achieve a particular task. Functions are what? Inbuilt programs that have been written for us so that we can use them to achieve any task we want to achieve. Now, formulas are now expressions that makes use of these functions. Functions are what? Inbuilt programs that have been written to achieve a particular task. Now, formulas are expressions that make use of these functions. So let's go through the lecture slide. Now, what are functions? Functions are what? Predefined or inbuilt programs. They are programs because every function is made up of several lines of codes that have been written so that we can achieve a particular task or calculation in Excel. So functions are inbuilt programs. So every function will always take in inputs. Every functions will always take in inputs. After you supplied the inputs, now several operations will be performed on the inputs, then the results based on the input supplied will be generated for us. For instance, sum is a function. That is, some function in Excel has input lines of code that have been written so that anytime we call some function, it will carry out addition operation on any range of data that we want to add. So now, what are formulas? Formulas are simply expressions that can be used to perform calculations. Formulas are expressions that makes use of functions to perform calculations. Formulas are expressions that can be used to perform calculations. Now, whenever we want to use our formulas in Excel, it's not a must for us to use function. But what we are saying is that with our formulas, there are still some inbuilt functions we can use whenever we want to write our formulas. So formulas typically start with equal sign. Anytime you want to use a formula in any cell, the first thing you do will be to select the cell and type the equal sign. So every formulas in Excel begins with an equal sign. So formula can be simple arithmetic calculations and it could still be complex calculations. Thank God we are now in the era of artificial intelligence. There are several artificial intelligence tools that we can use to generate formulas for complex calculations. We'll still be introduced to these AI tools that we can use to generate complex calculations. But before then, we still need to understand the basic things we need to know in order to use formulas during our calculations. For instance, this is a formula. It's an expression. And interestingly, this expression though is a simple expression and does not require the use of a sum function. Every formula always starts with an equal to sign. Then you reference the cell that contains the data you want to add. So now I want to add the content of cell A1 to the content of cell B1. So our formulas can also make use of inbuilt Excel functions. So it's not a must for formulas to make use of inbuilt Excel functions, but what I'm saying is that there are still inbuilt Excel functions that we can use in our formulas when carrying out our computations. Now, anytime we want to use formulas in Excel, we always need to use different operators. They are operators we are already familiar with. For instance, equal to, the operator is what? The equal to sign. Not equal to, that's the operator. Greater than, we use that for the operator. Less than, we use that for the operator. That's the operator for greater than or equal to. That's the operator for less than or equal to. And we also have logical operators, which are and, or, and not. Now, anytime you want to use and, all the conditions must be correct. Anytime we want to use and, we can have more than one conditions, but all the conditions must be correct. Let's see that example. And a1 greater than 10, comma, b1 greater than 20. In that example, we have two conditions. And the conditions are that the content of cell a1 must be greater than 10, and the content of cell b1 must be greater than 20. We always use and when we want all the conditions to be true. So in that example, content of cell A1 must be greater than 10 and the content of cell B1 must be less than 20. Now, in instances whereby we have many conditions, and if one of the conditions is true, we are okay. We can use all logical operator. For instance, take a look at that example. Or A1 equals to 10, B1 equals to 20. Those are two conditions. Now, we only need one of the conditions to be true in this instance. We also have the not operator. Not is a negation operator. That is, we are interested in the opposite of the condition. Take a look at that example. We have A1 greater than 10. And when we say not A1 greater than 10, that means we are interested in the opposite of that condition. That is, A1 should be less than 10. So these are different operators we can use anytime we want to generate formulas. Now, anytime you want to insert your formulas, you will make use of what we call the formula bar. Anytime you want to make use of your formulas, you type your formulas inside the formula bar. Formula bar is simply a text box where you can enter your formulas for data manipulation. And this is an example of the formula bar. Anytime you want to use the formula, you start by typing equals to, then you generate expressions, then the result will be inside your reference cell. Let's assume that I want to add the content of cell F2 and the content of cell G2 together, and I want the result to be here. I will double click this, then I will press equals to, then I will type the name of the cell, that is what? F2 plus G2. Then I will press enter. Then my results will be here. You can see I've added the content of cell F2 to the content of cell G2. Then my results will be placed here. Now let's see another way of writing our formulas. E2. Now you can select the reference cell. This plus, I want to add this, plus, I want to add this. Then you press enter. So that's how we can use our formulas without using functions. So Excel still has a formula ribbon that contains different groups of functions that we can use when writing our formulas. Now let me illustrate that. Now this is the formula bar. This is a group of functions that we can use when writing a formula. Under AutoSum we have sum. You can see the definition for sum. It automatically adds the contents of different cells. You can use average to find the average of data in different cells. You can use count numbers to count the number of numbers, the number of values in a particular cell. You can use max to compute the maximum number, the maximum value in a column. You can use min to compute the minimum value in a column. Now we still have these financial functions. It contains different functions that we can use for financial computations. It contains different functions that we can use for financial computations. We still have another group, the logical group. It contains different logical functions that we can use. And false, if error, if not available, ifs, not, or switch through, XOR. Now we still have different group of functions that we can use on our text data. Now we have character, we have clean, we have code, we have concat, we have let, we have length, we have lower, we have mid, we have proper, we have replace, we have write, we have search, we have substitute. Now we still have different functions we can use to carry out computations on dates. These are the different functions. We still have different functions we can use for mathematical or trigonometric calculations. Where perhaps we want to calculate cosine, sine, tangent, decimal. These are the functions we can use. We still have another tab called the more functions. You can see these are different functions we can use for statistical calculations. These are different functions we can use for engineering calculations. These are different functions we can use for cube. These are different functions we can use to generate information. These are different functions we can use to find out compatibility between our data. So Excel has rich functions that we can use. And the usefulness of function is that you don't need to write the lengthy lines of code. The codes have been written on our behalf and have been inbuilt into the Excel environment for use. Now, you can see now that we have several functions we can use. But in this lecture, we only focus on the top functions every data analyst must know. We only talk about the top functions that are very, very important for our data analysis task. The first function we always need whenever we are carrying out our data analysis is the if function. If function. Now, whenever you want to use if function, you always test a condition. Now, if the condition is now true, you can now specify the action that will be taken. If the condition is false, you also specify the action that should be taken. So the if function is used to automate decision making in our spreadsheets. With if, we could get Excel to perform a different calculation or display a different value that depends on the outcome of a logical test or a condition. That is, there will always be a logical test that will be carried out. Now, based on the output of the logical test, then we'll specify what should happen. If the logical test is true, we'll specify what should happen. If the logical test is false, we'll specify what should happen. Now, the if function asks you for the logical test to perform, what action should be taken if the test is true, and also the alternative action to be taken if the test is false. Now, this is the syntax of the if function. Take a look at this. If you specify the logical test using the logical different operators. Now, what should happen if the logical test is true? What will happen if the logical test is false? For instance, this is my logical test. I want to confirm if the content of cell D2 is greater than 7. If the content is greater than 7, what should happen? Display yes. If the content is not greater than 7, what should happen? Display no. So if function will always test a condition. Now, based on the outcome of the condition, you now specify what should be done if the condition is true, or what should be done if the condition is false. So now, I've come up with different questions we use to evaluate this if function. For instance, in our data set, replace zeros in column D with female and ones in column D with male. So now, how do we want to achieve this? So that means in column D, we have sequence of zeros and 1. And now we want to test the content of column D. If the content of column D is 0, we want female to be displayed in our result cell. But if the content of column D is 1, we want male to be displayed in our column cell. So let's see how we can achieve this. Now this is the data set we want to use, and this is the column D. It contains sequence of zeros and ones. Now let me check. There's still another. Okay, now this is still the same. This is still the same data set, but this data set is in tabular form. So we'll use the data set that is in tabular form. I'll still use the data set that is not in tabular form. Now, the beauty of putting a data set in tabular form is that we can use the filter option to quickly see the values. Now take a look at this. Now you can see in this cell I have zeros, I have zeros, in this cell I have 1, and in this cell I still have blanks. Let me quickly check why we have blanks. It's because for easy understanding, I deleted some cells in my tables. I deleted some data in my table. So that's the reason why we have blanks in my table. So now I want to use the if function to text the content of cells we have in column D. If it's 0, I'll display female. If it's 1, I'll display male. I want my result to be in this column K. So now let me start. Whenever I want to start my formula, I'll press equals to. Now, if is the function I want to use. Now, take a look at this. It's giving me the suggestion on what I need to enter. So I don't really need to cram or memorize the formula. If logical test. Okay, content of this cell, is it equal to 0? Put comma. If it's equals to 0, what should happen? Display female. Female. If it's not equals to 0, what should happen? Display male. Then close your bracket, press enter. You can see the content of the cell is 0. That is why we have male. Now let's use the autofill on this. Okay, autofill may not work here. Now take a look at this. Why do I have male here? The content of the cell is 1. That is why I have male. Why do I have female here? The content of the cell is 0. That is why I have female. So now, if I want to see the formula, this is the cell I tested. Is the content of this cell equals to 0? If the content is equals to 0, display female. If the content is not equals to 0, display male. So why do I have this? Is because my data set is in tabular form. Now, table 2 is what? The name of my table. And what? Gender is the name of the column. That's the reason why I have it in this format. So let me still try it on a data set that is not in tabular form. Okay, here equals to, if is the function I want to use. Where is the cell I want to test? This cell D2. If the content of cell D2 is equals to 0, what should happen? Display female. If the content is not equal to 0, what should happen? Display male. Enter. So now I can extend the formulas across all other cells, across all other row in my column. So this is how to use the if function to solve that. So now we've used the if function to replace zeros in column D with female and ones in column D with male. So now the second example, if the customer is a female and her annual salary is greater than 50,000, I should display qualified in column J, else I should display unqualified. Now, if you take a look at this question, you discover that we have two functions. You discover that we have two conditions that must be tested. I want to test if the customer is a female. That's the first condition. I also want to test if the annual salary is greater than 50,000. Now, I have two conditions. Now, for the result to be for a customer to be qualified, these two conditions must be met. This is instances whereby I will need to use the function and function because both conditions must be met. So now, customer must be female, annual salary must be greater than 50,000. So let me go back to my formula. Customer must be female. Okay, customer must be female. So for customer must be, for me to test if the customer is a female, I will check if the content of cell K2 equals to female and if the content of cell F2 is greater than 50,000. Let me write out the conditions. K2 must be equals to female. Condition 2, F2 must be greater than 50,000. Those are my two conditions. Now, let me now use if to generate that. If, I'll type if. So I'm expected to put my logical test. And now, what are the conditions? K2 equals to female. That's the first condition. What's the second condition? F2 greater than 50,000. Okay, those are my conditions. So now, if this condition is met, what should happen? Display unqualified. If this condition is met, display qualified. If the condition is false, what should happen? Display unqualified. Then I'll close my bracket and press enter. So now let me extend this cell, this column. You can see this particular customer is qualified. Why? The customer is a female and the annual salary is greater than 50. So now let me extend the width of this column. Now, why is this customer not qualified? The customer is a male, even though the annual salary is greater than 50,000, but the customer has violated one of the conditions. So anytime you want to use and, all the conditions must be met. And take a look at this. We can have any number of conditions. We can have any number of conditions. Let's assume that I want to add more conditions. Now, if M2 is equals to female, this is greater than this, I still want to add more conditions. Now, if content of cell, if the net worth, I even picked network instead of F2. Okay, if the net worth is, let's say if the net worth is less than 200,000, if net worth is less than 200,000, okay, you can see it's displayed unqualified. Why? We have three conditions. M2 must be female. Yes, M2 is female. F2 must be greater than 50,000. Yes, F2 is greater than 50,000. H2 must be less than 200,000. It has violated that condition. The net worth is greater than 200,000. So I have what? I have unqualified. I have unqualified. Now you can see almost all the customers are unqualified. Whenever we use and, we can have more than one condition. But anytime one of the conditions is violated, our result will be false. So that's how to use if condition. So let's see other examples that we have. In result data sets, assign respective grades to each student's total scores. Use this outline. If score is between 70 and 100, grade should be A. If score is between 60 and 69, grade should be B. If score is between 50 and 59, grade should be C. If score is between 45 and 50, grade should be D. If score is between 40 and 44, grade should be E. If score is between 0 and 39, grade should be F. This one that I initially said during our data analysis tasks, we can come across computations that are simple and we can still come across computations that are complex. This seems to be a complex computation. Now let's go through the Excel sheets we want to use. Now this is the students' results we want to use. Now these are the students results of students in a programming course, C programming, and okay, I want to know the total number of students. Let me go to the first row, press colon and down arrow key. Now I have 274 students. Now this is their CA, this is their exam, and take a look at their total scores. So now I want to use those conditions to generate the grade. Control home. I want to use those conditions to generate the grade. So that means I'll be testing the condition. I'll be testing the value in this cell. If it's between 70 to 100, grade should be A. If it's between 60 to 69, grade should be B. If it's between 50 to 59, grade should be C. And if it's between 45 to 50, grade should be D. If it's between 40 to 44, grade should be E. If it's between 0 to 39, grade should be F. This is a complex problem, and I know how to solve it. When we come across complex problem like this, let's use AI to handle it. Let's use what? AI to handle it, so as not to be frustrated. So in the next class, we'll talk about AI tools we can use to generate formulas for complex computations. So now what are our results? Replace zeros in column D. If D2 equals to 0, display female, or else display male. Now, if in new column J, if the customer is a female and the annual salary is greater than 50,000, display qualified in column J, hence displays unqualified. Now we can write it this way. Now take a look at these two results. This is the first condition. Now, is the content of cell D1 equals to 0? Now take a look at this. If the content of cell J1 equals to female, anytime you want to compare the content of a cell with a text, the text must be in quotation. That is what I want to point out here. Anytime I want to compare the content of a cell with a text, that text must be in a quotation. But here I want to compare the content of cell D1 with a value, with a number. It's not a must for you to be in a text. Now, in result data set, assign responsibility to each student's total score. Now, take a look at the results. If D1 greater or equals to 70, comma, result will be A. If D1 greater or equals to 60, result should be B. If D1 greater or equals to 50, result should be C. If D1 greater or equals to 45, result should be D. If D1 is greater or equals to 40, result should be E. Any other result outside of this should be F. When we come across complex computation, let's use here. Now the next function we want to try out is the SUMIF or the SUMIFS. Now this merge two functions together, the sum function and the if function. We do use the sum function for addition, and we do use the if function to carry out to test a condition before carrying out a task. So what we want to achieve with this is that we want to test a condition. Now, if the condition is correct, if the condition has been met, the content of a particular column will be added. Now, anytime we use SUMIF, that means we only have just one condition to be tested. But anytime you use SUMIFS, that means we have more than one condition to be tested. So now these functions are used to add values that meet a specified criteria. The function asks for the range of values to sum, and then each range to test, and what criteria to test it for. That is, whenever we want to use SUMIF or SUMIFS, we always want to add the content of a particular column based on certain criteria or condition that has been met. So now let's see. So why some if can only test one condition, some ifs can be used to add the content of a cell if more than one condition are met. Now take a look at this. This is the syntax. Some ifs, you specify the sum range, that is the contents of a column to be added. Then you specify the criteria range. Criteria range 1, you specify the criteria range 2, you specify the criteria. Okay, this for some if. So now let's see the practice questions we want to use. Generate the generate the cost total of cars in red color. What is the condition to be tested? Cars in red color. What is the column to be added? The cost column. So now let's see, generate the cost total of cars in red color. Okay, let's say our data sets. Now these are data sets. We want to use this cell equals to. We want to test the content of this column. If the color is red, then we'll add the cost. Okay, we use the if function. Sum if. I always like to use my formula this way. Type the formula will be suggested sum if as the cell specified by a given condition or criteria. Double click the function. Now it asks you to input the range, then the criteria. This is the range. What is the criteria? Equals to red. Now, what's the cell that will be added if this criteria is met? Sum this. Enter. Now, I've generated my results. Sum the corresponding values here if the color is red. So now let's check this color red. This is the color that is red. Let's see. Let's identify all the red. This is another color that is red. Okay, we only have 2. So now we are now saying if any color is red, sum the corresponding cost. Now, what's the cost for the first red? 3,000. What's the cost for the second red? 2,005. So we have 5,005. Now, let's see, try another one. Sum the corresponding cost for car colors that are blue. I want to write it here. Equals to sum if. Double click, specify the range. This is the range. Comma, what is the criteria? The criteria is it must be equals to what? Blue. Now, which sum should be added? Which contents should be added? This. Enter. Okay, now let me count. Where are the cells that are blue? One blue is there. Let's look for blue. Now this is blue. Where's the second blue? This is another blue. Is that the only blue? We only have 2 blues. Okay, this is another blue. Okay, so now let's sum 2000 to 2002. We have 4002. 4002 to this, we have 8,000 and 8,300. So that's how to use sum if. Now, in sum if, you only have one condition. You specify the condition to be met before the corresponding contents in a particular column will be added. Now let's go back to our practice questions. Generate the cost total for cars in red color and whose model is Accord. Now we have 2 conditions here. The cars must be in red color. The model must be Accord. What should I now do? If these conditions are met, I will do what? I will add the contents of cost column. So let me see how to do this. Cars must be in red, model must be Accord. Now, let me write here red. Sum of red cars. Sum of blue cars. Let me extend this. Yeah. Okay. Now here, I want to add what? Let me check again. Cars in red, model, Accord equals to, I have more than one condition. Sum ifs equals to sum ifs. Now, sum range. You can now see it's telling me what I should specify the column to be added. Costs, comma, criteria range. Model must be what? Accord. This is the first criteria. Equals to what? Accord. Now, take a look at the spelling of my Accord. A-C-O-R-D. Small letter, capital letter A, then C-O-R-D. Okay, that's the first criteria. What is the second criteria? Model must be Accord. Then, let me check. Model must be Accord. Cars must be red. The color must be red. This, then it must be what? Red. Now, I'll press enter. Now, two conditions must be met. The model must be Accord, then the color must be red. So let me glance through my data. Model must be Accord, color must be red. Total is 3,000. Do I have any other car that meets up this condition? Accord and red. No other meet up this condition. So this is how to use sum if. All the conditions, whenever we use sum ifs, we can have more than one condition. Whenever we use sum ifs, we can have more than one condition. Let me test another one. Generate the cost total of cars in red color whose millage is 41,000. Now let me write out the conditions. Cars in red, millage less than 41,000. I want to know the total cost of cars that meets up with that condition. Now, what's the condition here? Red cars, and millage less than 40,000. Okay, can I extend the width of this? Okay, sum ifs. Sum if, specify the sum range. Put comma. What's the first criteria? Red cars. This, put comma. Criteria is what? It must be red. That's the first criteria. Now, what's the criteria range 2? Millage. Put comma. What's the criteria? Millage should be what? Less than 41,000. Less than 41,000. Then now, it should be in colon. Yeah. So now let's see the car that meets up with this condition. Red car, red car whose mileage is less than 41. This is a red car, but the mileage is greater than 41,000. This is another red car. The mileage is greater than 41,000. Let me go back to this. Red car. I made a mistake. The mileage I put is less than 410,000. Okay. Now less than 41,000. Oh, you can see I have 0. That is, no car meets up with this criteria. So now let me go here and change it to greater than 41,000. Greater than 41,000 and press enter. Greater than 41,000. So red car greater than 41,000. Okay, this is a red car. This is a red car greater than 41,000. This is another red car greater than 41,000. Then I should sum the cost. I'll sum this and this. So that is why I have this. So this is correct. Okay, this is for what? Red cars model accord. Let me add it there. Red cars add accord model. So now let's see. Let's play with our formulas. Now what will happen if this is not in quotation? There will be error. So that means our textual values must always be in quotation. So that's the third question. Okay, compute car purchase amount of all female citizens. Compute car purchase amount of all female citizens. So let's see the data set for that. Okay, now these are the female citizens. Car purchase amount for all female citizens. So I want to add the car purchase amount of all female citizens. How will I do this? I only need just one condition. So I will use SUMIF equals to SUMIF. Double click this. So you specify the range. So you can now see whenever you want to use SUMIF, you first specify the condition before you specify the colon whose content should be added. But anytime you want to use SUMIFS, you first specify the colon to be added before you specify the condition. So let me now see, specify the range, then the criteria. Now this is the range. So what's the criteria? Must be equals to female, equals to female. Now, what's the colon to be added? This colon. Oh, I have 81,000. So the total car purchase amount for all females is what? Is that value I add? Is what? 818,888. So now, let's confirm. Here, I put female in this form, capital letter F. Let me change this to small letter F. I want to confirm if SUMIF function is case sensitive or not. SUMIF function is not case sensitive. So even if I wrote female in lowercase, or I wrote female with capital letter F, I'll still get the same answer. So SUMIF function is not case sensitive. Okay, compute car purchase amounts for female citizens in Bolivia. So now I have two conditions. For first condition, it must be a female citizen. Second condition, the female citizen must be in Bolivia. So I should compute what? The purchase amount. Let me write down the condition. Female citizen, country, Bolivia. Okay, let me go back to my data set. Sum A equals sum. Okay, sum range. You can now see, I'll first specify the sum range, car purchase amount. What are the criteria? Criteria range. female citizen. Let me choose this. I can choose this, female citizen. What's the range? It must be female. Now, it's not a must, it should be capital. Okay, what's the second criteria range? Country, Bolivia. Import to what? Bolivia. It's not a must, it should be capital. Enter. So this means there is no female citizen in Bolivia. Let me confirm that. Bolivia. The funniest thing is that we don't even have a country called Bolivia. It's because I've deleted some of the data sets. Now, let me look for, okay, let me put Iraq. Country, Iraq. Okay, I have this. So now let me confirm. Now, the citizen must be a female and the country must be Iraq. So let me use country first. Two conditions must be met. The country must be Iraq. The gender must be female. What's the car purchase amount? You can see this is the car purchase amount, 548, 54,827. Now, let me change this to Iraq. Let me change this to Iraq, and let me change this to female. Let's see what will happen. You can see it has added the car purchase amount for all these female citizens that are in Iraq. So let me change this to male, and let's see what will happen. You can see, so that means the only female citizen in Iraq, the car purchase amount is what? 51,130. Okay, let me see the next. Now, compute car purchase amount from female citizens of the following countries: Bolivia, Angola, Nigeria, Niger, Argentina. How many conditions I have? Female citizen, that's a condition. Countries: Bolivia, Angola, Nigeria, Niger, Argentina. I have how many conditions? 1, 2, 3, 4, 5, 6, 7. Let me use AI for this. So these are the results. So these are the results I got. Generate the total, the cost of cars in red color and whose mileage is less than 41,000. This is the formula. Compute car purchase amount of all female citizens. Compute car purchase amount from female citizens who is greater. Now compute car purchase amount from female citizens of the following countries: Bolivia, Angola, Nigeria, Niger, and Argentina. Let's use AI for this. So the next formula I want to talk about is the count A, count if, and the count ifs. Now, how these functions work is similar to how the sum ifs function works, but it won't sum the content of a particular column. It will only count the number of values in a particular column that meets a certain criteria. Count ifs will only count the number of values in a particular column that meets a certain criteria. So now let's start. The count function is used to count the number of cells in column that contains number. Count function is used to count the number of cells in column that contains what? Number, not text, number. Now let's try that first. Number of text, number of cells that contains number equals to count this range. Now, the cell in this range contains what? 40 numbers. Now, let's use it for a text and see what will happen. Let's use it for a text and see what will happen. Count. It says count the number of cells in a range that contains numbers, not text. Now let's see what will happen. If I want to use it to count the number of cells in country colon that contains numbers. 0. No cell in country colon contains numbers. Now let me put one number here and see what will happen. Then I have 1. So you can only use count to count what? The number of cells that contains numbers, not text. Number of cells in a colon that contains numbers, not text. Okay. The count A function is used to count the number of non-empty cells within a given range. The number of what? Non-empty. Non-empty. The number of cells that are non-empty. Now let's see how that works. Count A, number of cells that are not empty. Let me use this data set. Okay. Let me use this data set. Non-empty cells. Let me now specify the range D2 towards D25. Between D2 and D25, you can see between D2 and D25. So I have 21. So I have 21. So I'll be able to count non-empty cells. So from this, I can know that, okay, my cell contains what? Empty cells. And this question is, please count the number of males in colon D. That is, we want to count the number of males in colon D. There is a condition. In colon D, we have males and female, but we are only interested in counting the number of males in colon D. That is where count if will come in. We want to count based on a particular condition. And what is the condition? The contents of colon D must be males. So we use count if for this. It has just one condition. Okay, number of males in colon D. Number of males in colon D. Number of males. Okay, I'll use equals to count if number of males in colon D. What is the range? I'll select the range. So now I think it's always good for me to specify. Let me specify the beginning and the end. That is from what? Let me delete this. From what? Yeah. Okay, hold on. Let me delete this. This. I put a colon. D2 to where? To this. Yeah, D2 to D41. D2, D41. That's the range. D2 to D41. That's my range. I'll put a colon. So what's the criteria? Must be what? Equals to 0. That's the criteria. Equals to 1. I want to count the number of male. Equals to 1. That's the criteria. Then I'll close my bracket and press enter. So now I have what? 22 names. Let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 15, 17, 18, 19, 20, 21, 22. So that's the number of males in colon D. So the next question, count the number of female citizens in Brazil. I want to count the number of female citizens in Brazil. So now I have two conditions. Female citizens in Brazil. So that means the first condition is I want to count the number of female citizens. The female citizen must be in Brazil. So I'll be dealing with two columns. The column for the gender and the column for the country. So I will use Countifs. Okay. Females in Brazil equals to Countifs. Now, criteria range 1, female. Okay, that is what? D2 to D41. D2, D41. What's the criteria? It must be equals to 0. Must be equals to 0. Okay, what's the second criterion range? Country. That is what? C2. C2 colon C42. Okay, C41. Okay, now what's the what criteria? It must be equal to Brazil. I hope we have Brazil. Brazil. Now it's not case sensitive. I can write it this way, it's not case sensitive. Okay, it has even changed it automatically. When I'll press enter. So now I have just one female in Brazil. Okay, let me check. Now Brazil. This is a okay, this is a male. This is a male. Brazil. This is a female. So I only have two people in Brazil, one male, one female. So this is my answer. Let me check the code again. Double click. This is the Brazil. Country is Brazil. 0 is what? Female. Now that's that. The next question, can the number of Brazilians any more than 50,000? Number of Brazilians any more than 50,000. Now I have two conditions. Condition number 1, the individual must be a Brazilian. Condition number 2, the individual must be any more than 50,000. Now, since I have two conditions, I must use what? Count ifs. Brazilians any more than Brazilians any more than 50,000. Brazilians any more than 50,000. Let me extend the width of the column. Brazilians any more than 50,000. Count ifs. Okay. Double click the function criterion range 1. What's the criterion range 1? Brazilian. That is the. Wait a minute, let me confirm. Brazilian, that is C2 to C41. Now, what's the criteria? It must be equal to Brazil. Brazil. Okay, I'll close this. Okay, criterion in 2, any more than 50,000. That's annual salary. F2 to F41. More than what? 50,000. Greater than, more than 50,000. Greater than 50,000. Okay, I'll close this. Close my brackets, press enter. So we only have two Brazilians any more than 50,000. Let's confirm. Brazilian, this is one. How much is he earning? 59,000. It's more than 50,000. Let me check this another Brazilian. How much is the person earning? 82,000. So now that's how to use that. Okay, now these are my results. Count the number of cells in a column that contains number. Anytime you want to count the number of cells in a column that contains number, we'll use count. Cells in a column that contains number, not alphabet, not text. Count the number of cells that are not empty. Now, we can also use count. We can also use count if. Yes, that asterisk means it must contain a value. Now, count the number of cells. Let's test that. Count if. None. Okay, let me use another data set for this. Okay. Okay, here I use count A. Okay, I've used flash shell equals to count if. What is the range? D2 to what? D25, D25. Yeah, what's the criteria? Now, it must contain a test. It will be this way, then you put asterisk. Asterisk means it can contain anything. So it still was 21. So I can use count A. I can use count A to count the number of non-empty tests. I can still use count if. Okay, count the number of males in column D. I'll use count if, specify the range, and what one indicates male. Count the number of female citizens in Brazil. I'll specify this is the column for gender, 0 represents female. This is the column for country, Brazil represents the country. Count the number of Brazilians any more than 50,000. Now, this is the column for okay, this is the column for the country, Brazil. This is the column for the salary greater than 50,000. So these are to use count, count if, and count ifs. Now, the next formula to test is what? Concatenate. Concatenate is a function that can be used to perform operation on text. It can be used to combine text in different columns. The concatenate function combines values from multiple cells into one. This is useful for piecing together the different parts of text, such as someone's name, an address, a reference number, or a file path or URL. It prompts you for the different values to use. Now, this is the syntax. You start by indicating equal to, by putting equal to, concatenate, then you specify the different cells you want to concatenate. Okay, now I want to make and model using concatenate equals concat. Now take a look at this. We have to concatenate a list or range of text strings, join several text strings in one text string. We'll test both concat. Now I've upgraded my Excel. I'm using 2019 now. Concat. In other versions, you may have just concat function. So now what's the text I want to add? I want to this text, comma, then this text. I still want to add the column, then this text. Press enter. You can see now you will discover that I've made the content of make, model, and silver, but everything has been merged together. So I can use this to put space. Put space, 3 spaces in between, column. Okay. Yeah, you can see it has been spaced. Chevrolet Impala silver. So we can use, now let's test concatenation. Concatenation. Okay, text 1. I want to make this, comma, let me put space. I want to make this, comma, let me put space. Okay, now I want to make this as the final. Now, I've used concatenation to achieve the same thing. Now, let me add a number to this. I want to spot the difference. Okay, it's still the same thing. So we can use both concatenation and concat to achieve the same thing. I believe concatenation is the old formula, while concat is the old formula you can find in other older versions of Excel, while concatenations is the new formula that you can find in the new version. Both can be used to merge the content of a text, be it textual contents or numbers. So now the next function we must know is the left and right function. The left and right function. Now the left and right functions we do the opposite action of concatenate. If you want to extract text from a particular column, you can use from if you want to extract text, if you want to extract leftmost text from a column, you can use left. If you want to extract rightmost text from a column, you can use right, but you must specify the number of characters that must be extracted. Now let's see. They will extract a specified number of characters from the start and the end of a text. This can be used to extract parts of an address, URL, or reference for further analysis. The left and right functions request the same information. They want to know where the text is and how many characters you want to extract. Now, left, you specify the text, the cell that contains the text, then you specify the number of characters to be extracted, leftmost. Now, when you use right, that means you want to extract the rightmost characters from a particular text in a column. Then you specify the number of characters to be extracted. Now, practice questions. Extract the first three characters of countries. Left. Now, the cell range C2 to C. No. So I'll specify the text. Bulgaria. How many characters? 3. I'll press enter. Ball. Then I can extend this downward. Okay. So now I'm able to extract the first 3 leftmost character from the country column. Now let's see the next. Extract the last 6 characters in email column. Last 6 characters in email column. Now last 6 characters equals to right. You can see return the specified number of characters from the end of a string. Now email, comma 6, enter. You can see. Now let me drag it downward. So I've extracted the words, the last 6 characters, 1, 2, 3, 4, 5. So I've extracted the last 6 characters. You can see it's still counted dots. It's also a character. Let me test that on now. You can see the reason why. I believe you already know the reason why we have this. This is it's still referencing a particular cell. This is the name of the table, and this is the colon header. Now let's test that on a data set that is not in tabular form. It's equals to right, not the cell range, D2, B2 to what? B41, B2 to B41. How many number of characters? 6. Okay, now I can now use text field for this. So I've extracted the last 6 characters from that. So these are the results. The next function we want to use are words upper, lower, and proper. Upper can be used to convert the text in a particular column to uppercase. Lower can be used to convert the text in a particular column to lowercase. The upper function converts any text string to uppercase. The lower function converts any text string to lowercase. The proper function converts any text string to proper case. That is, the first letter in each word will be in uppercase, and all other letters will be in lower case. Practice question: convert make and models of the car to upper etc. So let's see what we can do with this. Okay, now customer. I want to convert all text in customer to lower case. What's the text? This. Now I've converted it to lower case. Lower. Okay, let me extend this. Okay, this is for upper. How to convert all text here to upper. Okay, this is proper. Okay. So you can now see how upper works. It will ensure that each word in the column begins with a capital letter while others will be small letters. So that's how we can use lower, upper, and proper functions to format our data. So the next function is what? Len. Len is used in data analysis to display the number of characters in any given cell. Perhaps you want to know for password, let's say for PIN, it's only 4 characters, and you want to ensure that all characters in the PIN colon are 4. You can use length to generate the length of the character. So let's see how we can use that. Okay, I want to compute. Let's say gender must be 1. Length of this, enter, this is 1. So I want to ensure that all the texts are 1. You can see all the texts are 1, so I can know that they are correct. That's how to use length. It's often used when creating text with character limits or when trying to identify the difference between product numbers. Now, the next is what? Substitute function. Substitute function. It is used to replace the existing string with a new text in a text string. Now, practice question, remove commas in millage column. Now, let's see, where is the millage column? Okay, not the data set, this data set. We want to remove comma. We want to test substitute. We want to remove comma in millage column. Substitute. Replaces existing text with new text. Okay, millage. I only need to specify the text. Old text 63, 512. What's the new text? 63, 512. Now, can now do this for the remaining text. Okay, you can see I've removed what? Comma from all the numbers I have here. I've removed comma from all the numbers I have here. So that's how to use substitutes. Now the next the next function is what? Now. Now is used to compute the current system date and time. If you want to know the current system dates, now I can just put equals to now. I want to know the current system date. Enter. You can see, you check the date here. The date is what? 5/8/2024, 10/20, and this is what? 10:21 a.m. So that's how to use now. Where we can use this now is if you have an Excel document that you've prepared and you want to indicate the date and time, you can just use this feature. Anytime the Excel document is opened, the actual date will be, the current date will be, will reflect. So today, this provides the current system date. If I'm interested in the system date alone, I'll use today. So let's say I have a task, I've finished the task and I want to put the date. So I finished the task on the 8th of May and I submitted it on the 10th of May. If I use this function, the recent date will always reflect in my Excel document. Now we also have days. It determines the number of days. If we want to compute the number of days between 2 calendar dates, then we can use what? Days function. It is commonly used to determine product life cycle or contract period. Perhaps you want to know if a product has expired. You can use days to generate that. Now this is a data set that contains dates. I want to test the date function on this. Can you see this? I have this because the content I have in the cell are more than the width of the cell. So I just need to come here and double click this to add this. So, okay. Now, equals to, what do I want to test? This. 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 Okay. I should choose the end date. End date. Then the start date. Start date. I'll press enter. So it's telling me between this and this, we have 214 days. So this is what 2nd of May and 2nd of December, 2nd of May and 2nd of December. Now let me change the format of the dates. I'll come here. I'll come to dates. Okay, now this will be more clear. Now you can see we have what? Between what? 2nd of May and 2nd of December. So the days between 2nd of May and 2nd of December is what? 214. So that's how to use the days function. Now network days is used to calculate the number of working days. Days, when we use days function, it's to calculate the number of days, all the days. But network days, we only calculate the number of working days. It will exclude Saturdays and Sundays. So let's compute that. Network days equals to net work days. Between this, start date should be this, comma, end date. Now we have 154 working days. Now let me confirm this again. I think I chose a wrong, end date, start date. Okay, network days, start date, end date. This is the reason why I always prefer that anytime you want to use it, type the function and follow the prompt. You can see for the network days, you first type the start date, then you type the end date. Check for this, for the days, end date first before you type the start date. Now the last function we'll be looking at is the vertical lookup function. The vertical lookup function. Now the vertical lookup function will look for a value in the table and it will now return information from another column that is related to that value. But that information must be in the same row of that value. Now the syntax is this. Vertical lookup, you specify the value you want to look up. Then you specify the range of values in your table. Now you specify the colon index number of the corresponding information that will be returned. Then you specify the range lookup. Now the lookup value, that is the value you want to look for in the first column. Now we must be careful anytime we are using lookup value, we must be careful. Number one condition is that the column must be sorted. The data must be sorted. You must use the first column to sort your data. Now the value you want to look up for must also be in the first column of your table. So the second criteria, you specify the range where the value will be generated from. Then you specify the column number in the table where the value is to be retrieved. The column number in the table where the value is to be retrieved. The return value that corresponds to the lookup value. Now this return value and the lookup value must be in the same row. Now you now specify the range lookup. You select true if you want the approximate match to be returned, or you select false if you want the exact match to be returned. So let's see how this works. Now let's see this first column. Now I will discover that the data in this first column has not been sorted. So the first thing I will do, I will have to sort the data. I've sorted data in ascending order or alphabetically. Okay, this is the make of the car, the make. The lookup value must always be in the first column. I want to look for the make of a car, and I'll return the corresponding, let's say I'll return the corresponding mileage of the car. So the mileage of the car is in what? Colon 1, 2, 3, 4, colon 4. Let me change this to mileage. Mileage. Let me change this to mileage. Mileage. Okay, so vertical lookup, lookup value. Any value I put in should be looked up. Okay, what's the table range? It should look for the value within this range. Now, what is the colon index number of the value to be returned? I want to return the mileage. The colon index number is what? 4. Now, do I want an approximate match of the value that is being looked up to be returned, or the exact match? I want the exact match. I'll click this, then press enter. So now I want to look for Chevrolet. Paste Chevrolet. You can see it has returned this mileage. Let's see, Chevrolet. It has returned the mileage of Chevrolet. Now let me look for Dodge. Now it has returned this is Dodge. It has returned the mileage for Dodge. Let me look for Ford. Now it has returned the what? Mileage for Ford. Now let me look for Honda. Honda, it has returned the mileage for Honda. Let me look for what? Nissan. Nissan, it has returned the mileage for Nissan. Let me look for Toyota. Now it has returned the mileage for Toyota. Now we must be very, very careful when using this vertical lookup function. If there are empty cells in the table, it can generate error. Also, to return the corresponding value for the first instance of the value it comes across. For instance, when I look for Toyota, you can only return the mileage for the first value of the Toyota it came across. So it can't return the return value for information about the second instance of Toyota in the table. Now when I look for Chevrolet, the mileage for Chevrolet, it will only return the mileage for the first Chevrolet it's looked for, and not the second or third Chevrolet looked for. So that's how to use vertical lookup. So these are the different formulas that I believe every data analyst should be conversant with. So in the next video, we'll see how we can use certain AI tools to trash up or to generate formulas for our data analysis task. We'll look at how we can use certain AI tools to generate formulas, complex formulas for our data analysis task. Thank you.